Okay, picking back up with lesson 7.1, it says f is x to the fifth plus x minus 18. First, it says prove that f has an inverse. You know, you probably don't want to have to graph it and do a horizontal line test. Let's instead take a derivative. What is the derivative of x to the fifth plus x minus 18? 5, x to the fourth plus 1, which, by the way, has to be greater than or equal to 0. So that means f is strictly increasing. It's always going up. Therefore, f has an inverse. Now, finding this inverse would be nightmarish. And I think it only takes a moment for you to see that. If I said find the inverse, you'd say, well, I'll switch x and y. But solving for y would be anything but easy. Look at that right-hand side. You'd have y to the fifth plus y minus 18. So that's bad. That's really bad. So it's very easy for us to say, well, we can't get the derivative of the inverse function because I can't even solve for the inverse function. I know there is one. My calculator could actually graph it, but I just couldn't solve for that inverse the way I did for example 1 and example 2. Well, we're going to use this idea right here to help us out. Absolutely. That's really what's going to be so liberating and helping us out. They're saying g is that inverse function. Find the slope to g at the point negative 16, 1. Please get into the habit of writing this. Negative 16, 1 lies on g. That's the inverse. What point lies on f? Yes, 1 comma negative 16, which, by the way, you could confirm in a second. You could plug in a 1 into that f function and quickly find out that the y value there is negative 16, right? That's a good thing to do. And right now you could say, well, how in the world could I ever find g prime of negative 16? That's really what they're asking me to do. Well, this relationship that we just saw up here is saying g prime, remember, if I were to say b comma a lies on g, that means a comma b lies on f. That's from the picture that we just saw right there. Two very different x values for our tangent lines, but it's a reciprocal relationship. So I could say g prime of negative 16 is 1 over f prime of what number? 1. You see, you're always going to have these different x values. And guys, the rest of this isn't so bad, honestly. I just want to point out to you that you're going to have these very different, you're never going to have the same numbers inside there, right? So we could real quickly see what f prime is. Well, you know, if you had one, if the point is on the line of y equals x, you're right. Then we could get that. You're right. Thank you. Okay, as we look at f prime of 1, though, we could say that's 5 times 1 to the fourth plus 1, and that would be a 6. Guys, your answer is 1 over 6. We are done. You now have the derivative of that inverse function, and you're just taking that reciprocal of the original function itself. Of course, you're evaluating at 2 different points. So get into the habit of always labeling your points, and then you're going to be able to work out your problem pretty quickly. Let's take a look at example 4. Again, here they're not asking us to prove that we do have an inverse. Okay, solving for the inverse here would be really, really bad as well. It would pretty much be impossible. They're not asking us to work out what the actual inverse is, thank goodness. But they want the slope of the tangent line to the inverse at 5, 1. So I'm going to say 5, 1 lies on G. What point then would have to lie on F? 1, 5. And it would only take you a second, guys, to confirm that. Plug in a 1 for your X, and you can see this 1 and the -1 are gone, and sure enough, you get a Y value of 5, right? So we have very different points of tangency. Just like what we were seeing up above here, the A, B and the B, A are very different from each other. So they're saying, could you find the slope of the tangent line of G? So G prime of 5, G prime of 5 would be what from what we just saw? 1 over F prime of 1. Is everybody okay with that? You're evaluating your derivatives at different points, at different X values. And that's so important. Guys, the rest of this really isn't so bad. You could say, well, what is F prime of X? F prime of X is 5x to the 4th plus 9x squared plus 2, which, by the way, is always positive. But look, I'd actually like to know what F prime of 1 is. So that's a 5 plus a 9 plus a 2. And help me, what is that? That's 16. So guess what? My derivative, my tangent line slope on another curve that I can't even solve to get the equation of it, it's going to just be 1 over 16 at that X value of 5. We doing okay? Label your points. It's a reciprocal relationship. And again, I can't stress enough, you're evaluating both of the derivatives at different X values. For G, it's plugging in a 5 into the derivative. For F, you're plugging in a 1 for the derivative. That's why it's so important to start with those points. What I'm about to show you probably is no surprise for me to tell you that this is straight from the College Board. And I'm going to put something like this on a future test for sure. I was just talking to Miss Vasta about it. She just taught her kids this. Ironically, like they taught something before us, in AB, but it's fine. We're covering a lot of ground. And, she was talking about how she was just doing table problems with the kids for good reason, because that's typically what the College Board focuses on. So let's look at this. The table aspect can get a little scary. And I'll be real honest with you. I think everybody, the first time they look at it, they'll say, oh my gosh, wow, I don't know here. Oh, wow, look at this problem. I don't see G. G is an inverse function. G is F -1 of X. And you look right there, you'd say, well, I don't have a chart for G. In fact, they're saying find G of 6. No calculus needed. No calculus needed. You'd say 6, something lies on G. Huh. Well, what do you know now if we have an inverse function? Something lies on F. Question mark, 6. And kids will say, well, how in the world am I supposed to find that? Well, you look at your table, you'd say, where is the Y value? 6. Oh, it's right here. You see that? So what is on F? 4, 6. So all of a sudden you'd say, well, hey, that's not so bad. I can do that. I'm sorry, I'm having some problems with the pen here. So we could say 4, 6 lies on F from the table. So what lies on G? 6, 4. So guess what G of 6 is? Done. Now, notice what the College Board, and this is actually straight from the AP Central here. G prime of 4. Wow. All of a sudden, you could say there's a reciprocal relationship. This is a calculus question, but here we go again. Before you get into the calculus, label the points. That's maybe the most important part of the whole problem. Label your points. G prime of 4, this is an x value. You'd say 4 comma something lies on G. That means something comma 4 lies on F. Well, what comma 4 do you think we're talking about? Right here. Wow. Oh my goodness. Look at that. They are trying to trip you up. And we've got to be so careful about that. Sorry, my tablet's a little bit slow here. So we've got 3 comma 4 lies on F. And that means 4 comma 3 lies on G. So they're saying find G prime of 4. Help me out. What do you think that is? 1 over F prime of 3. Like I said, different x values for the point of tangents. Here, it's actually cool. You don't even have to do any work whatsoever. What's f prime of 3? From the table, they tell you it's 5. Done. That's it. Last one is the one that can get kids really upset and scared. They look at this and they'll say, this has to be a typo, Mr. Dobner. I'm looking at this. It says G of 8. If I start at G of 8, that means 8 comma something lies on G. That means something comma 8 is on F. And you can frantically search that table. Guess what? You don't see an 8 showing up anywhere. And they're doing that on purpose. And you think, oh my goodness, I don't know. I'll give you a hint. G is an inverse. So what's f of f inverse of 8 going to get you? An 8. Aren't these undue functions? Don't they just wipe out? Wow. Wow. What are we seeing? F of f inverse of x, it's always x. Always. Whatever work F inverse did, F canceled it out. And it would be vice versa as well. If we would have had this, that would be X also. So, one last problem. And this one's a really good one for us to take a look at. It says, a particle moves along the x-axis so that its position is inverse tangent of t. Find the velocity of the particle when t is equal to 1. Now, what's so scary is normally you'd say, well, to find the velocity of a position function, I must take the derivative. And you don't know how to take the derivative of inverse tangent just yet. In a week you will. Well, maybe a week after, a little after because of Thanksgiving, right? But in the very near future, you'll know how to do that. Right now, you'd say, well, wow, if I call this g, which is an inverse function, what would the original function be? Tangent. Wow, that's your tangent function. Or you could say, what's the inverse of inverse tangent? You'd say, well, it's the tangent function. So I've got my f of t, and here's my g of t. And wow, right now they're saying find the velocity when t equals 1. So I'm going to say 1 comma something is going to lie on g. That means something comma 1 lies on f. Wow. What angle would I have to plug into tangent to get a 1? What do you think? Pi over 4. I could say pi over 4. Comma 1 is on f. So that means 1 comma pi over 4 lies on g. So g prime of 1 is 1 over f prime of pi over 4. What is f prime? What's the derivative of tangent, guys?